Friends, hi friends, welcome to my YouTube channel. Today we are going to discuss the whole flywheel topic for GATE and IES purpose in this single video. Believe me, if you go through this video, you will get all the concept of flywheel for GATE and IES in the single video and able to solve all numerical based on this topic whether it is of IES or of GATE. So without wasting any time, let's start the video. Let us discuss some basics first. See, this is a generator. This is the generator having two flywheels. This is the first flywheel and this is the second flywheel. Attached to it on both the sides. We all know that the function of flywheel is to store energy during the power stroke or working stroke of the engine and deliver it during the rest part of the cycle. Okay friends, now suppose friend, this is the diagram of the turning movement, that is the torque versus the theta, that is the crank angle. Now see, this is turning movement diagram of the engine. Suppose there is an engine here. Okay, this is our engine. Suppose this is the engine of this generator. Now the turning movement diagram of this engine is this. That is, this engine will produce certain power. Okay, and due to that power there will be a turning movement produced by this engine. Okay friend, I am just giving an example. The turning movement diagram can take any shape. It is just to show you the basics. We first understand this diagram. Here the power developed by engine will produce certain torque and the variation of this torque is shown by the turning movement diagram for one cycle of engine. Okay, so this is the turning movement diagram of this engine, that is the torque produced by this engine is shown here by these lines. And here the mean torque, that is this mean torque line, this is the mean torque line AH. Okay friends, here the mean torque line represents the resisting torque acting on the flywheel due to external influence, that is there must be certain load against which the flywheel is working. So that is the external influence and it is applying a torque on this flywheel. That's why this is the T mean, that is the resisting torque which is acting on the flywheel. So you understood what is this diagram. This is for the flywheel, that is the T mean part, and this is engine producing the torque which is shown by these curved lines. Okay friends, now we have to look at one important concept. The torque curve of engine cuts the mean torque line of flywheel at A, B, C, D, E and F. That is, the mean torque line is this, that is the horizontal line. This is the mean torque line, okay friends, and it is cutting the torque produced by the engine, that is this curve line, at points A, B, C, D, E and F, G. Okay friend, now the whole concept here is the determination of delta E, that is the maximum fluctuation of energy in this cycle. If you understood what is maximum fluctuation of energy, then you can do anything in this topic. So now concept is we have to find out the delta E for the cycle of operation of engine. Note one point, that this cycle is for one revolution, that is one revolution of the crankshaft. Okay friend, that is power that is being delivered by the engine in one cycle. So suppose this is, we know that for two stroke engine the working cycle is 4 pi, that is 4 into 180, and 2 pi for the two stroke engine. So we all know that. So this turning movement diagram is basically drawn for one cycle. This point you have to keep in your mind. Now friend, the concept is only this, that delta E can be find out using any of these methods. Okay, you have to find out delta E and the whole story revolves in this topic of around the delta E. If you understand delta E, you can solve any problem in GATE, you can solve any problem in ES. If you find delta E, the whole story is about delta E calculation. So delta E here is this. So delta E can be find out using this formula, or using this method, or using this method, or using this. Now I will explain one by one the procedure to find out the delta E. So in the first case, that is delta E is equal to energy E max minus E min. Now friends, see, this was our torque diagram. Okay, and it was cutting at A, B, C, D, E and F. The energy at the mean torque line. Now energy at these among these point, at certain point energy will be maximum, at certain point energy will be minimum. So suppose energy at point A is EA, energy at point at B is EB, energy at point is C, energy point at D will be ED, energy at point E will be EG. Similarly we can write. Now at these point, among these all points there will be a point at which energy will be minimum, and there will be a point at which energy is maximum. So delta E can be found out by subtracting the maximum energy from the minimum energy from the maximum energy. So for this, the d theta diagram problem, these problem are called the t theta diagram problem, and these problem are subjective type problem, and sometimes short problems regarding the simple torque theta diagram has been asked in GATE examination. A similar problem has been asked in GATE examination 2014 regarding this formula, this part of the formula. And if you wanted to know whole story about this process, that is the conventional part, which is Emax minus Emin problem, which are based on the conventional part, you can refer to my lecture number 33 for the delta E determination, that is the maximum fluctuation of energy, which is denoted by delta E determination, and the link is pasted in the description box, so you can see in the description box. Okay friends, now let us discuss the next part. So the next part is I omega square Cs. So this is another way of finding the delta E, where I is the moment of inertia of this flywheel, and omega square is the angular velocity, mean angular velocity of the flywheel, which is given as omega max plus omega min divided by 2, and Cs is the coefficient of fluctuation of speed here, which is given as omega max minus omega min divided by omega, that is the mean speed. So this is the another case. So most of the GATE problem, every year you will find a problem on this formula. Okay friends, so this is very important for GATE aspirant. This formula we can use to find out the delta E. Now look at this next thing. The next thing is that you can find out the value of delta E using this, because in certain part of the cycle, that is this is the whole cycle, at certain point the velocity of the flywheel or the angular velocity of the flywheel will be maximum, and at certain point of time the energy of the flywheel, the speed of the flywheel will be minimum. So you can find out the delta E, that is the maximum fluctuation of energy in the cycle, by subtracting the kinetic energy, angular kinetic energy, when the velocity of the flywheel was maximum, from the velocity of the flywheel was when the flywheel was minimum. So this is the another formula, where omega max is the velocity, maximum velocity in the cycle of the flywheel, and omega min is the minimum velocity of the flywheel in the cycle. So this problem has been asked in GATE examination and ES examination based on this formula, about the determination of delta E, based on the determination of delta E many times. So you can find out very easily, where I is the moment of inertia of the flywheel. Now the last thing, that is the determination of delta E, where the whole story revolves around the delta E. The next thing you can find out the delta E using this expression, that is delta E is equal to C into W, that is the work done in the cycle. W is the work done in the cycle. Now C is the coefficient of fluctuation of energy here. Okay friend, and the W is the work done in the cycle. Now using for this the delta E determination, for this formula, using this formula, delta E can be determined by finding out the W, that is the work done in the cycle, or C, that is the coefficient of fluctuation of energy. Now see how we will achieve this. Now work done in the cycle can be find out using this formula, that is the area under T theta diagram. That is, this is the T theta diagram. Okay, this is our T theta diagram. Sorry, this is our T theta diagram. Okay friends, this is our T theta diagram. Now area under this diagram, that is under this curve, okay, this curve, area under this curve can give us the work done, and it can be find out using the T mean into theta cycle, this formula also. The work done can be find out using this formula also, where T mean can be find out using power developed by engine, denoted by P, into 2 pi n, where n is the RPM of the engine, and divided by 60. So T mean can be found out using this, and theta is 4 pi for 4 stroke engine, and 2 pi for 2 stroke engine. So you can see this accordingly. So this is the way of finding delta E. And the next thing that I want to draw your attention toward is the IES and GATE hard problem, that is the conventional problem. In this problem this the equation of this torque, the varying torque, the engine torque, which is varying like a sinusoidal way, that is like this, that is this wave variation, this that I have shown in this diagram. Okay friends, in this diagram I have shown you this. Now friends, the equation of this curve is given to us in certain cases. So you can find out the value of delta E using this curve also. And these problem comes under the category of hard problem or conventional problems. A similar problem has been asked in IES examination and I have solved that problem, and you can refer to my lecture number 30 for that, and the link of that lecture I have shown there, I have pasted in the description box, so you can look at this particular topic. And if you able to solve that problem, I have explained that problem in a very simple way. If you are able to solve that problem, then you will be find it very fortunate that you have find such a good method of solving the problem regarding this. And in many of the university examination, this type of problem has been asked also you can find such problem in gate also. So you can solve this problem, that is the variation of torque, where the equation of the torque is given, that is this is the torque produced by the engine. Okay, and the equation of this torque is given in the terms of theta, that is the angle where theta is the revolution of the crank, that is the angle of the crank of revolution. Okay friend, so for this you can refer to my lecture number 30 or 29, maybe it may be 30 or 29, I am just forgetting right now, but you can see my lecture number 30 or 29. For that you will find the problem based on this torque, variation of torque, and the in the equation form where the torque is given in the terms of theta. Okay, so you can find the whole problem which was asked in IES 2003 regarding this. So the main story here is, so thus I am summarizing the topic. The main story here is only to find delta E. If you are able to find the delta E, then you will able to solve any problem based in flywheel. So main concept here is delta E. You should find delta E by using all these methods that I have shown you. And you are able to, if you are able to do that, you can do any problem in the flywheel concept. Okay, so that was all today's for topic. That was all for today's topic, and thank you friends for watching the video. And if you like my channel, you can subscribe to my